Welcome to this video from In 28 Minutes. Thanks for helping us provide awesome learning experiences to more than 300,000 learners across multiple platforms, Udemy, Safari, and Pact. Let's welcome our lead instructor, Rangarao Karanam. Welcome to this section of the course, JPA in 10 Steps. In this section, we learn the basics of JPA and also how it compares with the earlier attempts of storing data to database. How does it compare to JDBC? How does it compare to Spring JDBC and MyBatis? We will understand the basic concepts of JPA, entity, mappings, entity manager, and also relationships. We'll also understand how Spring Data JPA makes it easy to use JPA. To make things easy for us, we'll use an in-memory database, H2. The home folder for this section of the course is inside Spring Web Services. There is a folder called JPA in 10 steps. If you go in here, you'd find the details of each of these 10 steps, a few useful links related to H2 console, and also the complete code example. At the end of this section, we'll again start looking at RESTful web services and enhancing them to connect them to JPA. I'm excited to introduce JPA to you. I'll see you in the first step. Welcome to this video where we are going to discuss a little bit of theory about Java Persistence API. What we want to understand is what is the problem that Java Persistence API is trying to solve, and what were the alternatives to Java Persistence API, and how does Java Persistence API solve that problem. That's basically what we would want to understand. The next couple of steps will be a little bit of theory. If you are a hands-on guy, then it might be a little boring for you, but I think it's important to understand the theory behind Java Persistence API. What is the problem that Java Persistence API is trying to solve? Think about it. The programming language we are using is Java. We want to take data from Java. Where do you want to store it? In the database. How are databases designed? Databases are typically relational databases, right? Nowadays there are a lot of big data and other stuff, NoSQL stuff, which is coming into picture. But even now, for the most part, we use relational databases. And in relational databases, we use tables. In Java side, we have objects. On the database side, we have tables. How do we store data from objects to tables? The way we design Java programs is using object-oriented programming. So we use object-oriented concepts. However, on the database, we use something called normalization. Object-oriented programming typically consists of concepts like encapsulation, inheritance, interfaces, polymorphism, and things like that. However, when we talk about relational databases, we are talking about things like tables, foreign keys, primary keys, first normal form, second normal form, and third normal form. There is a mismatch between these two. There is a mismatch between how we design objects and how we design tables. But we would want to establish a relationship between them. We would want to establish a mapping between them. Let's consider a few examples of this impedance mismatch. I have a very simple example here. I have employees and tasks, right? So you have an employee who can have multiple tasks, a task which can be associated with multiple employees. And what we would want to think about is what are the possible mismatches when you are trying to map this problem statement to objects and tables. Let's look at the first example right now. The first mismatch is in terms of the basic details. An object is made up of fields. Table is made up of columns. How we name the fields is different from how we name the columns. For example, here we are using DESC, and here in the table the column is description. Here we are calling it target date. However, in the table we are saying it's target underscore date. Is done, is underscore done. This is kind of a basic trivial example. Let's think about relationships between tables. Relationships. Employee can have multiple tasks and a task can have multiple employees associated with it. So how do we represent it in Java? Employee will put a list of tasks to him. So employee class will have a list of tasks. This is how we put it. And a task is associated with a list of employees. This is how we recognize that in the Java world, in the object-oriented world. How do we do that in table? Typically, in a table employee task, we create a new table called employee underscore tasks and show the relationship in there. So the way we design the tables is different from how we design our classes or objects. How do you take data from here and store it in the table? And the third example is multiple classes are sometimes mapped to a single table. So here we have employees, two kinds of employees, full-time employees and part-time employees. Full-time employees have a salary, part-time employees have a hourly wage, and you can see that these extend employee. There are three classes here, but when we talk about tables, we just have one table. We have an employee type to distinguish between full-time employee and part-time employee, and we store the values of the part-time employee in hourly age. So this is one of the attributes which is specific to part-time employee, and for full-time employee we are storing this salary. The data from these three classes has to be stored to just one table. Until now, we were looking at a few examples of object relational impedance mismatch. What we were talking about is the fact that how we design our objects is different from how we design our tables. And that's really the problem that all persistence frameworks have been trying to solve. Typical frameworks which were used to solve the persistence problem were JDBC, Spring JDBC, and MyBatis. In the next video, we'll look at how those frameworks tried to solve the problem of object relational impedance mismatch. In the last video, we talked about object relational impedance mismatch. We saw how we design tables is different from how we design objects. We discussed that there are three options that were used before JPA: JDBC, Spring JDBC, and MyBatis. In this video, we'll get an introduction to how JDBC, Spring JDBC, and MyBatis solve the problem. If you're already familiar with that, you can skip this video and move on to the next video where we would be discussing about JPA. The other approaches before JPA were JDBC, Spring JDBC, and MyBatis. In JDBC, Spring JDBC, and MyBatis, what we do? We write queries. Once we write the queries, we need to do two things. One is these queries have parameters. So over here, if you look at it, these are called parameters. Update to do, set user is equal to something. So these are all different parameters. So I would need to populate these parameters. So once you write the query, you need to set the values for these parameters. The other thing I would need to do is once the query is executed, for example, I'm executing this query, right? So I would need to take the values from the query. So the results are coming back in a result set. I would need to take the values from the result set and store it to the bean. Here the bean is to do. So I would need to take the values from the result set and put it to the bean. If it's an update or a delete query, then you don't really have any results coming back. But if you are doing a select query, then you have results back. So you need to take those results and populate into your Java objects or beans. How did JDBC do that? JDBC is basically Java database connectivity. And the way it did it was through things like statement, prepared statement, result set, etc. So what we do is we write a query. So we write a query and then we had to create a statement or a prepared statement for it and set the parameters into the query. Set each value. So we said the value here is 1, the value here is 2, here is 3, and so on. And once the query is executed, if it's a select query, then we would need to get a result set and we would need to map manually. What we would need to do is to do something like this. We would say we would get the result set and then take the values from the result set and put into the bean. So we are explicitly doing that in here. You can see that I'm actually taking one by one from the result set and putting it into the bean. If you look at the code that we wrote with JDBC, it was a little complex, right? So just to update something, just to do a simple update, I had to write like 15-20 lines of code, and I'm not even talking about exception handling code in here. This kind of becomes really a lot of code that I would need to write. What Spring JDBC did was it tried to provide a layer on top of JDBC. Instead of using low-level things like statement, prepared statement, other things, JDBC said, I'll provide you a JDBC template. You use the JDBC template. If I wanted to do an update, I still had to write the query. The basic approach is still the same. You had to write a query. But what JDBC template did was it made mapping parameters to query very easy. So it said, okay, you can call JDBC update with your query and all the parameters. What I'll do is take the first one and replace it here. Take the second one and replace it here. Take the third one and replace it here. And also it introduced a few simple concepts like row mappers. By default, if your names match, then you don't really need to create a mapper at all. So then you can use something called bean property row mapper. But if you want to define a mapper, then go ahead and create a to-do mapper. Once you create a mapper, this mapper can be used in multiple queries. Over here, we are using this to-do mapper to map the results from the query to the bean. So what it is returning is a to-do. You can see that all the logic I would need to typically do in JDBC, I don't need to do that when I'm using a JDBC template. So what did Spring JDBC do? Simply provide a simple layer on top of JDBC so that I can easily map parameters to queries and easily take the results from the result sets and map it to Java objects or beans. Now, what's the other framework which came in? MyBatis. Actually, sometimes people call MyBatis as an ORM framework, object relation mapping framework. But I don't really think it's object relational mapping framework because it's not really mapping objects to tables. What it does is it maps objects to queries. MyBatis provides a simple XML or annotation based configuration. So whatever mapping that we did earlier from your parameters to queries and taking values from the result sets and putting them to beans, what we can do with MyBatis is you can do the same stuff using XML or simple annotations. In JDBC or Spring JDBC, what we used to do is we used to write queries like this. So we used to put question marks and we would use to replace the values. But what MyBatis did is it provided a simple mapping framework. So instead of question mark, I would say hash user. And what is user? User is the name of the attribute in the bean. For example, over here you can see target date. Target date is equal to target date. And what is target date? Target date is the target date from the bean. If I wanted to use this query, it's very simple. I just need to say I want to update. I want to use this update query and use this bean. Because you have already mapped the name of the field in here, MyBatis would be able to recognize that and execute the update statement for you. We took a quick look at how things were done with JDBC. We took a quick look at how things were done with Spring JDBC and also MyBatis. The fundamental thing for all these three approaches was the fact that they are still based on queries, right? We still write a lot of queries. The problem with queries is when relationships between tables change, then you have to modify all your queries. I have worked in a lot of applications where there were a lot of big queries which were written. Like I've worked in applications where there were queries of 100, 200 lines of code. And understanding these and maintaining these is a really tough job. You need to really have a great understanding of how things are done in the database to be able to write these queries. And that's the real problem. The problem was the queries were becoming so complex that it was difficult to really maintain them. And whenever there were changes in the relationships between tables, it was really becoming difficult to maintain these queries. That's the world where JPA stepped in. In the next video, we'll look at how JPA tries to solve this problem. Welcome to this video where we would try and understand how JPA solves the problem of object relational mapping. The problem we were talking about is the fact that the application classes, the way we design our objects, is different from how we design tables on our database. So the way we design this employee, task, part-time employee, full-time employee objects is different from how do things on the database. Task, employee, employee tasks. So how does JPA solve the problem? JPA provides a mapping. You can map application classes to tables. You can say this class maps to this table. With JPA, you'd be able to define mappings between your classes and the tables using things like entities, relationships. You would use something called an entity manager to manage your entities. I would want to save a task to the database. I can use entity manager, give it a task object, and it would be able to save it to the database. I would want to get the values of a certain amount of tasks, or I would want to get the values of all the tasks related to a person. I can use the entity manager. JPA also has these features of criteria API and JPQL, which provides additional ways of finding data from your database. So I would want to find some data from the database. I would want to do some certain kind of searches against the database. Then instead of using SQL, you can also use JPQL or criteria API to query the database. JPQL is similar to SQL. However, you would be using entities instead of tables in JPQL. And Criteria API represents a way where you can write JPL using Java APIs. Before we get our hands dirty with JPA, we'll look at a few examples of how you can map application classes to database. Earlier, we looked at an example where in the task table, there was a mismatch of how things were in the task class or the task object and the tasks table. How do we solve that? JPA provides annotation. So here there's an annotation called @table. The @table annotation helps you to map your object to your table. So here I'm saying, okay, this task is going to be stored. An instance of class task would be stored to the entity task. I'm representing this as an entity by putting an @entity annotation on top of it. And also I'm saying this ID is a primary key by putting an @ID on top of it. I'm saying this description field which is present in here should be stored in a column called description. So that's how we map. So we are saying description, target date. So in the table it's called target date. So how do we map it? By putting @column, name is equal to target date. So this is a simple example of mapping fields to columns. You can also establish relationships between the different entities. So employee is an entity, task is an entity. We already looked at the fact that they have a many-to-many relationship. You can use an annotation called @many-to-many. So here I'm saying @many-to-many and @many-to-many. This establishes a many-to-many relationship between the employee and the task class. And the third example which we looked at was the full-time employee and part-time employee. These classes are all mapped to just a single table in the database. They are all mapped to employee. So JPA provides an inheritance mapping. So it says, I would want to use an inheritance mapping. The strategy is one table. All the subclasses of employee are stored to one table. And we are also saying, how do we distinguish is using the employee type. So we are also saying that in here. So we are saying the discriminator column is employee type. In this specific step, until now, we looked at a few examples of how JPA provides mappings between your objects and the tables. The most important thing that you need to understand is we are just trying to highlight a big picture of how things are done with JPA. If you're not able to understand these things in depth, that's not a problem at all. We are going to do a lot of this stuff step by step in the future steps. In this step, we took a quick overview of the big picture of JPA. We saw how JPA helps us to map objects to tables. We looked at how we can map specific attributes, specific fields to table columns. We looked at examples of how to map relationships, and we looked at how to map inheritance relationships between objects as well. The idea behind this step is to give you a quick flavor of what you can do with JPA. We have not really got our hands dirty yet. In the subsequent steps, we'll start getting our hands dirty. Welcome back. It's time to get our hands dirty. In this step, we'll create a simple project using Spring Boot. We'll use something called Spring Initializer. Spring Initializer is very useful to create your Spring Boot projects very quickly. We would want to use Maven, so I'll use Maven project, language is Java, and I would use a Spring Boot version of 2.00 snapshot. I think any of the versions which are greater than 2.0.0 should be fine. So you can just go ahead and choose snapshot or any higher version of 2.0.0. That should be cool. And I would want to use the group com in 28 minutes learning JPA. And let's use the artifact ID JPA in 10 steps. One of the things that you would need to choose when you start creating a Spring Boot project is what dependencies you would want, what starter projects you would want to use. Let's add in web because at later point we want to add REST services. So let's add in web and we would want to use JPA. So I'll write JPA in here and press enter. And the other thing which we want to do in this specific examples is use an in-memory database. In-memory database provides you a lot of advantages compared to installing a real-time database. We'll discuss a lot about in-memory database as we go on. So we'll add an in-memory database. The in-memory database we are going to use is H2. So I'm adding H2. We chose Maven, language is Java, any version greater than 2.0.0 of Spring Boot should be fine. And we gave a group ID of in 28 minutes learning JPA, com in 28 minutes learning JPA, and use an artifact of JPA in 10 steps. We chose web, JPA, and H2 as the dependencies, and we are ready to create a project now. So just click generate project. This would download a zip. You can unzip the zip to some folder on your hard disk and open up your Eclipse. I'm clicking generate project. This would download a zip into my local machine. I've opened up Eclipse and I'm ready to import the project in. So I would need to say file, import existing Maven projects. Actually, I want to use existing Maven projects and say next. I've copied the folder where I have copied the zip file to. I've extracted my zip file to this folder called JPA in 10 steps. So I just need to copy that folder in here, or you can even browse to it. So you can click browse and browse to the folder. Okay, I've done that, and you can see a project coming up in here. So this has our group ID and our artifact ID. So JPA in 10 steps, and we use the group ID com in 28 minutes learning JPA. I can click finish. When you click finish, what Maven does, it would start to download all the Maven dependencies. Inside our dependencies, we have chosen web, JPA, and H2. Web and JPA are actually starter projects. Spring Boot Starter Web and Spring Boot Starter JPA. Spring Boot Starter Web would help us develop web applications. JPA would help us develop JPA based stuff. There are a lot of dependencies that Spring would need to be able to set these up. What is happening in the background right now is all these dependencies would get downloaded and a project would be created. This might take a few minutes, so be patient. And once the entire thing is set up, you'll be able to see simple things like this. So you should see a source main Java with a simple application file in here, source main resources with an application.properties, and you should see a source test Java with a simple test which is present in here. You can see if you open up the Maven dependencies, there are a lot of Maven dependencies which are present in here. The most important dependencies as far as the Hibernate and JPA are concerned are Hibernate JPA API and the Hibernate Core 5.2.10 final.jar. These are highlighted in the screen right now. One of the questions frequently in the minds of people who are beginning to learn JPA is what's the relation between JPA and Hibernate? JPA is an interface. JPA is a specification. Hibernate implements JPA. It's like you have an interface and you have classes implementing that interface. Similar to that, JPA is an interface and Hibernate is an implementation. JPA defines all the annotations. So these are the different annotations which you can use. These are the different things you can use to define criteria queries. These are the different things that you can use to define attributes. That's what JPA defines. And Hibernate provides implementations to all these concepts. Once you map an object, once you put all the annotations on a class, Hibernate would be able to read them, understand them, and would be able to save your entities to the tables. Hibernate is one of the most popular ORM frameworks. ORM is Object Relational Mapping, and JPA standardizes ORM. So JPA says, okay, this is the way we should do ORM. This is the way you should define mappings between objects and tables. What does JPA do? It says, okay, this is the way you define entities, this is the way you map attributes, this is the way you map relationship between entities, and this is the way you manage the different entities. That's basically what JPA does. Hibernate is the implementation. Whatever JPA defines, Hibernate implements it. Let's get back to what we were doing. We were setting up a simple project. So let's start this and see if it starts up fine. So the way I can execute it is by saying right click, run as Java application, and you'd see that the application would start up. We have not really defined any entities as of now. We have not really mapped anything. We have not created any tables or anything of that kind. For now, let's just start the application. It should not do anything right now. The application starts up. You can see that in here. We are using Tomcat as the server because that's the embedded Tomcat which comes in built in with Spring Boot Starter Web. And we see that the application has started up. What we'll do in the next steps is we would start adding more features. We will start adding entities and try mapping them to tables. Welcome back. In this step, we would start looking at entities. In the previous step, we had set up a simple project. There are things which we need to still understand about that project. We'll understand them as we go. And now let's focus on creating a simple entity. What we want to do is to create an entity called user. Let's create a simple class. So class, name it as user. I would want to store it in a separate package. I would want to just say is entity and say finish. Now you'd see that the user is created in a package called entity. That's cool. So this is where we would store all our entities. This is the package where we would put all our entities in, and user is an example entity. What we want to have is a few attributes in the user. So I would say first thing is an ID. So I'll say instead of public, actually it should be private long ID. And I would want to store a couple of attributes of the user: private string name and private string role. One thing you need to understand is this is not really perfect design, because a name might have first name, last name, and other stuff. So you might really need to actually have a class called name. Ideally, you would want to have an enum defining that. Let's keep things simple for now. So let's just have strings, and I would also generate the getters and setters and stuff like that. So what I'll do is right click, source, and say generate getters and setters. I would only want getters, so I'll say select getters and say OK. I will also create a toString. So right click source, generate toString and say OK. It would generate a toString method for us. And also what I'll try and do is to generate a simple constructor. So generate constructor using fields. Ideally, we will not use an ID field in the constructor. So I'll remove the ID. I'll use the other fields. So we have a constructor in here. It's a simple constructor. 2 parameters, name and role. One of the things that JPA expects in every class is a default constructor. So if we create a constructor like this, then we are overriding the default constructor which is provided. JPA expects a default constructor, so let's go ahead and define a simple default constructor as well. So this is just like a simple bean. There is nothing JPA specific in it right now. It's a simple bean. It has 3 attributes: ID, name and role. It has a simple constructor accepting name and role, and it has a couple of getters and a toString method. This is very similar to any bean that you would define. There is nothing JPA specific in here. So now I would want to take this user and I would want to store it to a table called user in the database. So I would want to actually take the data from user and be able to map it to a table. How do I do that? Then I would need to make this an entity. So if I want to be able to store this user to a table, then what we need to do is we need to define an annotation. So that's at entity. As we discussed earlier, we are going to use the javax.persistence. Javax.persistence is the package where Java persistence API annotations are present. So I'll use javax.persistence entity. You can see that that's imported in here. So entity specifies that a class is an entity. This is something which would be persisted to a database. What we'll do is we'll also want to say this is a primary key. How do I say this is a primary key? By using another annotation called at ID. User has a primary key called ID. This becomes the primary key. One of the things I would want to do is I don't really want to assign the primary key. So I would want this to be generated. How do I make this to be generated? By saying it's a generated value. I'm adding an annotation saying this is a generated value. So until now, we have created a simple entity called user. We added an annotation called entity, and we added a couple of annotations on the ID field, ID and generated value, to say that this is something which is generated. Once we have created an entity, we would need to be able to save this to a database. How do we store entities to the database and get them from the database? The way we would do that is by using something called a entity manager. In the next step, we would start defining a service to get these values from the database. In the last step, we defined a simple entity. We would want to be able to save this entity to the database. What we would need to use? We would need to use an entity manager. To be able to save this user entity to the database, I'll create something called a user service. So let's say new user, new class. We would want to call that user DAO service. So we are creating this a DAO service in the sense that it's a data access object. So this is something which helps us access data from the database. So that's why I'm calling it user DAO service. I'm clicking finish. One of the things is I would want to move this to a package instead of dot steps. I would want to actually create it in a service package. What I've done is I've moved the user DAO service to the package JPA in 10 steps service. So now we have this class, and in this class we would want to be able to manage user entity. We would want to be able to save users and retrieve users from the database. One of the first things that we would need to do to be able to get the values from the database is create an instance of an entity manager. So I'll create a private entity manager. I'll import JavaX persistence entity manager. With this entity manager, I would want to be able to save data to the database. So I'll create a save method, public long insert, and this would accept a user and save the user down to the database. Let's import the user. How do I save an entity to the database? User is an entity, right? There is an annotation at entity defined on it. How do I save it? Entity manager provides a method. So entity manager dot persist. Persist is the method which can be used to make an instance managed and persistent. I'll say persist. And what we want to do is once the user is persisted, we want to return the ID of the created one. So user dot get ID. This user DAO interface is something which helps us store things to the database. In Spring, we call that kind of components as a repository. So a repository is an annotation which is defined in Spring framework. So you can look at it or Spring framework stereotype. Repository indicates something which interacts with the database. The other thing is when we want to insert, we want to modify something to the database, you need to be inside a transaction. What we would need to do is we need to be able to do something like open transaction here, open transaction, make the change, whatever changes that you would need to do, and then close the transaction. Instead of implementing transaction management in each method, what JPA provides is a simple interface to do declarative transaction management. The way we can do that is by saying transactional. So you can use this annotation on the class as well as on the methods. We are using javax.transactional. That's the thing which is imported in. So this says each method would be involved in a transaction. Other important thing that we need to understand is the concept of a persistence context and how it relates with the entity manager. If I say user Jack is equal to new user Jack admin, it creates an instance of the user. Here I'm creating another instance Jill. I'm saying entity manager dot persist Jack. So now Jack is something which is managed by the entity manager. Entity manager is actually an interface to the persistence context. When I say something that persists Jack, what it does is it saves it to the database and also starts tracking it in the persistence context. Jack is now inside the persistence context. So whatever changes I make to the Jack are now being tracked by the persistence context. Important thing to understand is entity manager only tracks those objects which are persisted through it. So here I'm creating something called Jill, and Jill, I'm not doing anything with the entity manager to Jill, and I'm saying Jill.set role, changing the role of Jill. This will not be tracked by the entity manager. Only those things which are in the persistence context are tracked by the entity manager. So we need to put an annotation so that this is auto-wired. So what is the annotation? It's persistence context. So I'm going to use an JavaX annotation, JavaX persistence annotation, persistence context. This is cool, right? So I have a service which is having a simple method called insert to save the user. Now I would want to be able to call this and be able to save this data down to the database. Let's do that in the next step. In the previous steps, we defined an entity called user and we created a DAO service to manage this entity. I would want to be able to call this DAO service at some place. One of the things that we have already set up is a simple project which launches up a Spring context. So this project, because we created using Spring Boot and uses a Spring Boot startup, this is already starting something called a Spring context. What we can do is At the launch of the Spring context, we would want to insert a user in. How do we do that? There's a concept called command line runner. So these command line runners are typically executed when the context launches up, when the Spring context launches up. You don't really need to worry about the context stuff right now. All that you need to remember is the fact that this command line runner launches up when the application starts up. So whenever we start the application, the code in the command line runner gets executed. Let's create a simple command line runner. I'll call this new class user because I'm talking to the service. So I'll say user DAO service command line runner. This command line runner, I would want it to be managed by Spring. So I'll say add component and import. To make it a command line runner, I need to implement an interface. So the interface, as you can guess, is command line runner. So I can import the command line runner in. Now I have to implement a method called run. So I would want to implement the run method inside the command line runner. Inside this run method, I would want to be able to save the user. So I would want to be able to say user is equal to new user of Jack. I would want to give him a role of admin. I would import the user in, and I would want to be able to do a persist for this. I would want to be able to save him to the database. How do I save him? I would need the user DAO service. I'll say user DAO service. I've created a simple instance of the user DAO service. I would want Spring to auto-wire it in. I'm saying import auto-wired. That's cool. I would want this user data service, user DAO service to save this data. So how do I do that? Insert user. One of the important things is the fact that the user DAO service also returns the ID back. So what I'll do is I would want to log this ID. So I would want to save, like log the ID which was created. To be able to log it, I would need a logger. So what I've done is I've used the logger factory.getLogger for this specific class. Actually, it should be here. So it's user DAO service command line runner class. I'm getting the logger. I'm using SLF for J here. So I'm going to use SLF for J. We created a simple logger so we can log this stuff out. So now I would say log.info, and I would say new user is created plus user. Okay, let's take a quick look back at what we are doing. So we implemented the command line runner interface because we would want this to run at the launch of the application. We added in a user DAO service because that's what allows us to insert a user. We created a user, we called insert user, and we are logging it. That's basically what we have done until now. Let's launch the application and see what happens. Right click, run as Java application. If you get a port conflict, what you need to make sure is that you kill the earlier instance which was running. I've already killed that instance and started a new one now. So let's see what happens. It's starting up, and one of the things that you would see at the startup in the log is the fact that it prints a new user. So new user is created, user ID is equal to this. So this is present in the log. So what we are able to do now is we are able to successfully save something down to the database. The thing which you need to understand here is the fact that we have not really created a database yet. How is this magic happening? Where is this data really getting stored to? Where is the database present? Do not worry about that. We'll look at it and more in the next step. Until now, what we have created is very simple, right? We have created a simple entity called user. We have created a service called user DAO service to be able to manage the user. And we are calling DAO service in the command line runner. So at the launch of the application, we are calling the service to be able to store the user in. And we saw that the user was created fine. This is a lot of magic that is happening. What's the magic that is happening in the background? That's basically what we would look at in the next step. In the previous steps, we created entity, we created a DAO service, and we created a command line runner to be able to save the data down to the database. However, there were a lot of unanswered questions. The first one is, where is the database created? What schema is used to create the tables? Where are the tables created? And so on and so forth. In this step, let's answer all those questions. The simple answer is all the magic is happening because of Spring Boot and its startup projects. Let's open up our pom.xml. When we created this project using Spring Initializer at start.spring.io, we chose three important dependencies. We chose web, we chose a starter called starter data JPA, and we chose H2 as the database. Let's focus on the in-memory database first. That's H2. Typically, we are used to databases like MySQL, Oracle. For all those kind of databases, you need to first install them on your machine, then create the tables, and then you'd be able to save the data from the application. This would mean that there is a lot of setup involved. Other kind of databases called in-memory databases. These databases are directly created inside the application. The schemas are defined, the tables are created, the data is populated, and once the application stops, the entire database is destroyed and removed from memory. The great thing about these databases is you don't really need to maintain them. I don't really need to install manually. I don't need to install the tables in there and all that kind of stuff. I'm going to application.properties. This is where we can configure the Spring Boot application. And what I would want to do is spring.jpa.showSQL. I'm making it true. So I would want to show the SQL which is generated, and the other setting I would want to turn on is something called spring.h2.console.enabled is equal to true. So I would want to see the SQL which is generated, and I would also want to enable something called H2 console. Let's stop the application and start it again. There are a few important things that you would see. You would see that there's a sequence being created and a table being created as well. There's a sequence called Hibernate sequence and the table called user being created. The other thing you would see is that there is an insert into user name role ID. These are the queries which are being executed. I can see them now because I turned on logging for queries. I said spring.jpa.showSQL true. We can see that the table is created and the data is inserted into it. Can I see the data in the database? One of the important things that you need to note is the URL is localhost 8080/h2 console. So it's h2-console, localhost 8080 h2 console, and we need to use a DB URL of JDBC h2 mem test baby. So JDBC h2 mem test DB. So I'm going to h2 console. You can leave these as a default. So if we want to connect to the generic h2 embedded, and this is the JDBC URL. So we are putting a JDBC URL of JDBC h2 mem test DB, and I'm saying connect. And now you can see the database. You can see the user table. The user table is created, ID, name, and role. I can do a select star from it. So I'm doing a select star from it, and you can see the row which is inserted in. What I would recommend you to do is to play around with this. We saw that the database is created in memory using H2. We saw that the schema also is being created at application startup, and also we saw the tables which were created. We saw the data in the database as well. Even then, a couple of important questions remain. Who is creating the data source? How is the schema being generated? Answer to all that is Spring Boot and the auto configuration of Spring Boot. So the entire magic is done by Spring Boot auto configuration. To be able to understand Spring Boot auto configuration much more, what we'll do is we'll turn on debug logging. Logging.level for org.spring framework. So for Spring framework, I'm turning on logging level to be debug. That's basically what we are doing in here. And let's restart the application. If you look at the log now, because we turned on debug logging, you'd see a lot more logging. There is something called an auto configuration report which is printed. I'll extract a few things from here. Here is a quick preview of what we observed in the log. One of the things is Spring Boot is intelligent. It identifies if you are connecting to an in-memory database or not. Since it saw that there is H2 on the dependencies list, it has configured an in-memory database H2. You're using H2 in-memory database. So Spring Boot knows that if you're using an in-memory database, then you'd want to initialize this schema. So it is able to understand whether your database is embedded or not. So it sees, okay, you're using an embedded database, so you'd want to initialize the database. So it uses Hibernate property called create drop. So it creates the schema at application launch up and drops the schema when the application is terminated. That's number one. The other auto configuration step that is enabled is Hibernate JPA auto configuration. Because we have Hibernate on the class path, Hibernate JPA auto configuration is triggered. Other things which are auto configured are a data source. There's a data source which is auto configured, and entity manager factory is auto configured, and the transaction manager is auto configured. If you actually look through the log, there are a lot of other stuff which is auto configured by Spring Boot. What we are looking at are some of the important things that are auto configured from the perspective of JPA and Hibernate. Auto configuration is a very important feature of Spring Boot. Spring Boot, what it does is it looks at the classes which are available in the class path. It looks at the jars which are available in the class path, and it decides what is the best configuration for you. For us, it decided that because H2 is in the class path, because Hibernate is in the class path, I'm going to use Hibernate with JPA. So I'm going to use Hibernate as the default implementation for JPA. And it also decided that I would want to use H2 as the in-memory database. And it auto-configured the schema for me and also auto-configured the entity manager, the data source, and a transaction manager for us. So all this happened in the background. And that's why when we ran the application, we were able to easily execute the queries against the database and insert a user row into the database. In this step, we were trying to answer the important questions. Where is the database created? What schema is used? What are the tables created? How can we see the data in the database? How are we getting Hibernate data source and all other stuff? We saw that the answer to all of this is Spring Boot and the in-memory database H2. We had to do no project setup, no configuration at all. Using an in-memory database, we don't really need to maintain anything. I don't really need to install a database or something of this kind. This makes it a great combination for learning and for writing unit tests. The other important thing is with little configuration, with some simple configuration in the application.properties, we can actually really connect to a SQL database or an Oracle database. The only problem with using an in-memory database is the fact that the data is not persistent between restarts. So as soon as you terminate the application, the entire schema and the data is lost. In this course, at the start, we would start using an in-memory database because of all the flexibilities it provides. In the last few steps, we created an entity called user and we started managing it with user DAO service. Let's say I want to create another entity. What I would need to do in that kind of a situation is to manage it. I would need to again go and create another DAO service. So let's say I would want to create another entity. So some entity DAO service, and to insert here I would say some entity, and let's just call this entity. Where you are writing a user DAO service is very similar to some other entity DAO service. So here we are just inserting the data, but consider the scenario when I'm inserting, I'm retrieving data, I'm deleting, updating, and all that kind of stuff. So if I have a lot of methods here, then those kind of methods are repeated again and again for all the different entities. If I have 15 entities, I would have 15 DAO services which would be having very similar logic. So irrespective of the entity, you have to interact with the entity manager to manage it. So you have to either call a persist method, or you would have to call something like a merge method, or you would need to call a remove method, or you have to call one of the variations of the find methods. Spring Data wants to solve that problem. What Spring Data says is you just define your interfaces. You define your repository interfaces and I will take care of implementing them. So if I want to just do a user DAO service, instead of that, I can create a simple repository with a small method in the interface, and Spring Data says, I'll provide the implementation for you. I'll be able to talk to the entity manager and do what you would want. The specific implementation or the specific module for JPA is Spring Data JPA. Let's now use Spring Data JPA to create a simple repository. The way we do that is very simple. All that we need to say is file, new, interface. The most important thing is we are creating just a simple interface. We are not going to provide the implementation. The implementation would be provided by Spring Data JPA. With this interface, we need to implement or extend actually another interface which is present inside the Spring Data JPA, which is JPA repository. So import the JPA repository. When we are extending the JPA repository, we need to provide what is the entity that you would want to manage. The entity we would want to manage is user. So I would want to manage user, and the other thing I would need to provide is the primary key. The primary key of user is long. This is all you would need to be able to create a repository. Now I would want to use this repository from our command line runner. So what I'll do is I'll go ahead and create another command line runner. I'm copying the user service, user DAO service. I would actually call this now user repository command line runner because it uses the user repository. I'll open up the user repository command line runner. I would want to change this. I would not want to use user DAO service. I would want to use user repository now. So import user repository. Instead of Jack, I would want to, let's say, insert Jill from here. I'll use the user repository dot save and say user. One important thing about the user repository is the fact that whether you want to update or insert, you would use the same method, which is save. This would actually return a user back. I would not need to worry about it. So I'll say user repository dot save user. Let's now run the application and see what happens. So I'll stop this and start the application. You would see that the insert queries are fired twice because we have two runners. We have one runner which is making use of the DAO service, the other runner which is making use of the user repository. And you would see that new user is created would be printed twice. You can see that Jill is also now created. What we did in this step is actually we used a simple user repository instead of a user DAO service. The user repository kind of acts as a shortcut to manage your entities. Instead of writing a lot of DAO services with very similar logic, so you would have the same insert persist logic, merge logic, find, and all that kind of stuff. Instead of using that kind of logic, Spring Data JPA provides a common abstraction called JPA repository. If you extend the JPA repository and provide the entity you would want to manage, you would get all the different methods that are provided, a varied range of methods that are provided for doing all kind of operations with your entities. In this step, we looked at one of the operations that was present. What we did from the user repository command line runner is we made use of the save method. What we'll do in the next step is make use of more methods that are defined in Spring Data JPA. Until the next step, bye-bye. Spring Data JPA makes it easy to manage your entities. Once you have defined your entities and defined the mapping to the database, that's it. Spring Data Repository would provide a lot of useful methods to manage them. In the previous step, we made use of the save method. Let's start with using a few more methods. One of the important methods which is present in the user repository dot find. So if I want to find by ID, I can use the method find by ID. And you can see that the find by ID uses a long. So I'll say I'd want to find the user who has an ID 1 and assign it to a local variable. This actually returns an optional. So I'll say user with ID 1. And I would say user is not created, but this is actually retrieved. So I've got the user who has the ID 1 retrieved from the database. The other options user repository provides is to query all users. So let's say dot find all, and I'll assign this to a list, and let's call it users, and let's also log all users plus We are using a couple of methods from the user repository. Actually, user repository has a lot of other methods. So you'd see that user repository has a count method, a delete method. You can actually delete in batch, and you can check whether something exists or not. You can do wide variety of searches using find, and also you have methods to save. So save method is used to insert and also to update an entity. There are a wide variety of methods that are there in the user repository. I would recommend you to try and see what are the methods that are there and try to play around with them. For now, let's restrict ourselves for these two things and let's start running the application. I'll stop this and start it again. The application will take a while to launch up because we have put it in debug mode. So now it's completed execution. If you look at the log, you'd see a few things that are printed. So one of the things which is printed is user is retrieved. So we are able to retrieve the user with ID 1. The name is Jack and we see the role is admin. And also we see all users printed in the log. So all users, user with ID 1 and ID 2. So we are able to retrieve all the users back. We saw how user repository is very useful in simplifying interactions with the entities, in managing entities. So now with Spring Data JPA, all that we need to do is define the entities. So once you have defined entities, Spring Data JPA makes it really easy to manage those entities. Until the next step, bye-bye. In 28 Minutes is providing awesome learning experiences to 300,000 learners across platforms like Udemy, Safari Online, and Pact. We have clocked million hours of learning in the last few months. The question is, what do you want to learn next? We are building solutions to help programmers at all levels. You can learn programming with our awesome courses on Java, Python, and JavaScript. You can learn full stack development with REST APIs and microservices with a wide range of frameworks like Spring Boot, Node.js, React, Angular, and Spring Cloud. We have 200 plus videos to help you start your journey from a programmer to a software architect. We have videos to help you learn frameworks, industry trends, including things like microservices. Learn the best practices in architecture, design, and code quality. Thanks for watching. Keep learning in 28 minutes.